Hello, welcome to the recording of our session. My name is Gage Huston. I'm the General Manager at Muscatine Power and Water. Also joining us today will be Doug White, our Director of Power Production and Supply. This is a re-recording of the customer forum that we held on May 19th of our Powering the Future initiative. When we did the original session, the recorded file that we took unfortunately got corrupted immediately upon saving. And despite our best efforts working with IT gurus both inside and outside the organization, we were unfortunately unable to recover that file. So we've re-recorded the session, trying to provide the same information that we provided during the live session so that folks that weren't unable to attend can hear the same information. So thank you for joining us today, and we'll go ahead and get started. Here's our agenda for the session. I'll start out by providing just a really brief background of MPW and the role that we play in the Muscatine community. And then I'll talk a little bit about our strategic plans for a cleaner future for Muscatine. Then I'll turn it over to Doug White, who will provide an update on our power supply transition activities and how we got to where we are today. And then he'll turn it back to me. I'll cover a few additional considerations on this topic. And then in the original session, we had some live Q&A from the participants, and since we can't replicate that in this re-recording, I'll direct you to some information on our website where we have a lot of information on this topic, as well as several FAQs that will provide some of the same information that we covered during that Q&A session. MPW, as many of you probably know, is a nonprofit municipal utility, and what that means is we're set up by a vote of the community to serve the interests of the Muscatine community. And we've got a long history going back over 120 years of serving Muscatine. What this means to you is first and foremost local control. You have local staff and local board representation that are making decisions purely in the best interest of the Muscatine community. Also, we focus on low rates and not profits. I like to say there's nothing wrong with profit, but as it relates to our operation, there aren't any profit considerations that need to be taken into account, and that allows us to focus on long-term best decisions for our customers and for the community. And then it really is about neighbors serving neighbors. So most of the folks that work at MPW are members of this community. A lot of us are customers ourselves. And so when we're making decisions or serving the community, we're really serving our neighbors, our friends, our family members. And I just truly believe that that makes a difference in how you make decisions and how you serve the utility. I'd like to talk a little bit about what you can expect from MPW as a utility provider. The first is dedication to customer service. I can tell you our employees are dedicated and care about how we serve this community. I see it day in and day out. The second is a standard of excellence. We take a lot of pride in being members of this utility, and so we have a high bar for how we operate, and we try and set that standard of excellence in all that we do. We also have continued reinvestment in Muscatine. So when we do our capital planning, our 10-year budgeting, we're focusing solely on investments we're making to make our system here in Muscatine better, as compared to a private provider that might have to compete for capital dollars for multiple cities or even multiple states. We're allowed to just focus on Muscatine. And we set our rates based on cost of service. So anytime we adjust electric or water rates, we back that up with an independent third-party cost of service study. That helps ensure that we're setting our rates and allocating costs to different customer classes based on the cost to serve those customers. And we're really proud of our utility. We take a lot of pride in serving this community and doing it to the best of our ability. And we want our customers to have pride in MPW as well. MPW has a long, proud history of serving Muscatine, with the electric utility dating back to almost 100 years now. And local power generation really has been a cornerstone of that, producing our own electricity here in Muscatine all the way from the beginning of when the utility was established. And that low-cost, reliable energy really has been a building block and an economic advantage to our community over that time. I've mentioned in other forums that we undertook a very comprehensive strategic planning session last year that built into our 2021 strategic plan. I won't go through the entire plan today, but we'll be focusing on Strategy 4, which is our Powering the Future initiative. Under Strategy 4 are really 4 key objectives that we'll dig into a little bit today. The first is to expand our renewable portfolio. The second is to investigate replacement options for our local resources. The third is we want to reduce our environmental impact. And then the fourth objective is to ensure that we transition our power supply in a way that's very reliable and very safe for our employees and customers. Digging a little bit further into the objectives, you can see one of the things we're going to be doing is investigating the development of a 30 megawatt local solar farm to serve the Muscatine community. We're also going to continue to track customer interest in renewable energy offerings to make sure that we're keeping up with the customer demand for those types of offerings and can meet their needs. As I mentioned, we will investigate replacement resources for our local resources we have now. And as you can see from the graphic there, we've set some very aggressive carbon reduction targets over the next decade with at least a 25% reduction by 2024 and at least a 65% reduction by the end of the decade. And I think with the plans we're putting together so far, we can outperform that, but these are some very aggressive targets for us to hit. In the meantime, though, it is crucial that we continue to operate our existing assets in a way that's reliable and safe. And that means that our local power plant employees and assets remain extremely valuable to this community in the coming years. When MPW looks at power supply planning, we really focus on 4 fundamental factors that you see here on the slide. First is reliability, then affordability, flexibility, and sustainability. And our perspective is it's really important that you keep all of those factors in balance when you put your solution together. If you focus too much on any one single factor, the other factors can really get compromised. And so our perspective as we put a plan together is that we find a balanced solution that encompasses all of those different considerations. Digging into that a little bit deeper, MPW has a very long history of serving the community in a reliable way, even being recognized multiple times by the American Public Power Association for our reliability metrics. This is just an expectation that our customers have come to rely on. Affordability is really important as well. We've got a long history of low rates below state and national averages, and we understand how our rates directly impact the households in this community as well as the business operations, because those utility bills can have an impact on how competitive those businesses are in their industries. The third is flexibility. So as you may know, the electric industry is undergoing some very significant changes, and it's really important that as we plan for the future, we have a power supply plan that can remain flexible and accommodate those changes. And fourth is sustainability. So we do understand and consider the impact that our operations have on the environment. And so we consider air quality, water usage, and climate impacts as factors when we plan out our power supply. So how do we get from those 4 fundamental pillars to an actual plan for a power supply transition? And I'm going to turn it over to Doug here, who's going to walk through some of that process of how we go through that planning to get recommendations to move us forward. Doug, take it away.
Thanks, Gage. Hi, my name is Doug White, and I'm the Director of Power Production and Supply here for Muscatine Power and Water. I've been here over 30 years, but most of my career has been spent either operating or maintaining the equipment at the generation site. I want to thank you for taking the time to listen to this presentation. And I'm going to talk a little bit about the bulk electric system, our current generating assets, the most recent power supply study, and where we're at with the recommendation investigations following that study. As Gage had mentioned, this is a re-recording of this presentation that originally was given on 5/19 of 2021. I'm not sure I'll make it exactly the same, but I can assure you that my shirt and tie are the same as the last presentation. I'm going to go ahead and shut off my video so it doesn't block any of the slides. So the bulk electric system has evolved quite a bit since MPW started producing electrical energy back in the 20s. MPW has been a member of the Mid-Continent Independent System Operators Wholesale Market since 2009. I'm just going to call that MISO from now on. Being connected to this MISO system provides a redundant supply of energy to our local system and allows us to support the bulk electric system reliability. This is a picture of the MISO footprint, which extends all the way from Manitoba, Canada, clear down to southern Louisiana. It's a big chunk. MISO's role is really to balance the system energy flow and to supply energy at each connection point at the lowest cost. These connection points are called nodes around here. It's important to note that the price of energy isn't the same at each point, and that's really driven by the cost of supply or the generation available and demand of the load at that point, along with transmission constraints and congestion. This system is really dynamic and pricing changes every 5 minutes. One of the advantages we have of local generation is right here you can see that we're connected to the same point we purchase power from, and this works as a power market hedge. MPW can sell excess power into the wholesale market when the price is high, or reduce generation and produce power when the market prices are low. This flexibility ensures MPW customers are supplied with reliable energy produced at the lowest cost. The bulk of power generated by MPW in 2020 was produced by Unit 9 due to its higher efficiency. Unit 8A also has a high efficiency and a capacity factor, but a relatively small electric energy output. Steam sales from Unit 8A, this combined heat and power unit, has been mutually beneficial and has reduced the utility's overall energy costs for over 20 years. This benefit really helps to stabilize rates. In 2016, MPW began incorporating renewables or wind into our power portfolio with energy produced by the 13 megawatt South Fork Wind Farm. That South Fork Wind Farm generated over 8% of the energy produced by MPW in 2020. As a renewable resource, that South Fork Wind Farm produces one renewable energy certificate, or REC, for each megawatt hour produced. MPW's Choose Green program is a tool that brings renewables from the areas capable of producing it, like South Fork Wind, to areas that aren't suitable through the sale of those RECs. REC sales increased dramatically in 2020, really indicating an increased local renewable interest. So power supply studies, well, why do we do them? Well, power supply studies help utilities plan for the future. Power system changes involve a great deal of time, planning, and a heck of a lot of money. Performing these studies gives MPW a blueprint to make sound decisions to continue providing reliable, low-cost energy for decades to come. Some of the drivers for the study that was completed in 2020 were that, well, it's just industry best practice to perform these studies every 3 to 5 years. We've also seen declining natural gas prices that are impacting the coal generating plants, cost declines and technology improvements in both wind and solar. And we've got encroaching environmental compliance deadlines and those associated costs for our existing units. The previous study was completed in 2016 and recommended a new 161,000 volt transmission line that will offer us a redundant power supply. The project planning is complete and construction is scheduled to begin this year. The completion of this line will allow us the retirement of Plant 1, Units 7, 8, and 8A in 2023. The power supply study was completed by an outside engineering firm using statistical modeling analysis software. The comprehensive analysis used 20 different portfolio scenarios evaluated under 4 different market cases or sensitivities, which resulted in nearly 4,000 potential outcomes. The software's goal is to determine the lowest cost and risk portfolio to serve Muscatine's native load for the next 20 years. There are local factors that are outside of the scope of the study that MPW must evaluate further. They include system reliability, local system control, economic impact, and environmental considerations. I think it's important to talk about the different types of generating assets and their respective outputs relative to their nameplate rating. Renewable energy sources such as solar, wind, and hydroelectricity really have a lower annual output due to the availability of their energy source. The plant may be capable of producing the electricity, but its fuel, the wind, sunlight, or water, may not be available when you need it. That's why 100 megawatts of installed solar puts out an annual average of about 25 megawatts an hour. The upside is that the fuel is free, and for solar, it's generally produced at peak times of the day. On the flip side, a 100 megawatt natural gas-fired unit has a really high capacity factor and would be capable of producing an average of about 87.5 megawatts per hour. These assets all come with fuel costs, though. Thermal units like coal, gas, and nuclear are dispatchable, meaning the output can be adjusted to meet demand. Most renewables are not dispatchable, and they're considered intermittent. Capacity factor and dispatchability are important when looking at the value of energy. Price is one factor. Reliability, or the ability to produce energy at the exact moment it's used, is the other. That's why a diversified energy portfolio really makes sense, balancing price and reliability. In the simplest terms, the power supply study recommended MPW consider transitioning toward more efficient and cleaner energy sources, which include the expansion of renewables and a switch from coal to natural gas. The study also recommends diversifying our portfolio and underbuilding, leaving an open position for future energy addition as technology changes. Specifically, the study recommends investigating 30 megawatts of solar at our Grandview Wellfield site, exploring the option of another 30 megawatts of local solar off of that site, evaluating the economics of a new gas-fired combined heat and power unit and a potential steam cell extension. We're going to be planning for the retirement of Units 7, 8, and 8A in 2023, and tentatively plan on the Unit 9 retirement by 2028. Diversifying and leaving an open position for future additions, and purchasing from the market in the short term. Solar was selected as part of the portfolio because of the known cost over time, and those act as a pricing hedge. This high-level timeline illustrates the milestones and multiple board decision points. We've already started this investigation process and believe this project could be completed before 2024. Customer interest and commitment through the Choose Green Muscatine and a new Green Rider program we're working on will determine if MPW moves ahead with this project. Well, MPW received 21 proposals for the solar RFP, and each proposal contained multiple options. MPW is currently evaluating the 140 options. The proposals will narrow to a short list, and those will be notified about 6/18. And on a parallel path, Ryan's T&D team is working on a transmission integration study, and they're collecting costs to connect the projects to the MPW system. That's now been received. The Muscatine County Solar Zoning Ordinance adoption was actually completed on 5/27. And the short list, when we get a little closer, the short list is going to be narrowing to a successful developer, and we'll start PPA negotiations at the end of June or in July. The MISO connection queue deadline is 7/22/21, and this is really important because MISO analyzes all the new projects on an annual basis, and they're all grouped together and analyzed at the same time. If you miss the deadline, you're in the next year's queue. We'll also have Iowa Utilities Board filings, and we hope to have that PPA contract approved by the end of this year. If we do, construction would begin mid-2022 and be complete by the end of 2023. So what would it take to go 100% renewable? We're interested, so are folks outside of here, so we dug into it. And to achieve 100% renewable supply, that's solar plus batteries for us, since we don't have enough wind speed for wind turbines, it would require about 870 megawatts of solar to supply the native system load and charge the 150 megawatts of batteries. These batteries would have to store about 14 hours of energy, or a little over 1,600 megawatt hours, to get us through a day. The solar array cost would be over $1 billion, and the battery storage system costs would be about $460 million, and those batteries would have to be replaced about twice during the 30-year life of the solar array, and that adds another $770 million of O&M. These are lithium-ion batteries, and they're similar to the ones that are in your cell phone. Even at these costs, we wouldn't get through 2 cloudy days. So system upgrade costs aren't included in this estimate either. So from the stack bar chart, you can see in December, this is pretty balanced. This black line indicates our load. This orange section indicates the hours that solar is generating energy. So everything below the line is energy that's used to supply our native system load. Everything above the line is charging the batteries. The blue bars indicate the batteries, and you can see that they're carrying the load on the hours that the sun isn't shining. This is a balanced system. So we take a look at the same amount of solar energy in June, and it's a little different. You can see here's our load profile in June. You can see that there's more days where the solar is charging, but in this, the difference really comes in right about here, because this darker orange indicates when it's charging. This gold color indicates when we're selling into the market. So at about 11:30 in the morning, the batteries are all charged and we're selling into the market. And if you recall from one of the earlier slides, I said we're in a supply and demand market. So at this point, we're going to be oversupplying into the market, and that'll tend to drive the prices down. And since we have a PPA, our price is going to be fixed. So it's kind of a take or pay contract. So this is likely an area where we would lose money in June. Just a little feel of scale here for the size of the footprint of this. This map represents the 7,000 acres that would be required for a 100% renewable portfolio. This is a square laid right over the top of the city of Muscatine with some landmarks on it for feel of scale. So the land required for this solar generation, though, is really dependent on the site conditions and the technology used. Solar panels can be fixed, single axis tracking, dual axis, and bifacial, or any combination thereof. So it really determines how large the area is. It is dependent on the technology that you're using. The second major recommendation is to investigate a new gas-fired combined heat and power, or CHP unit. Combined heat and power is also known as cogeneration and refers to the use of recovered exhaust heat for use in another process, resulting in improved plant efficiency. Following the energy through the system, the gas comes into the gas turbine where it's burnt, and this gas turbine is very similar to a jet engine. So you can envision the exhaust from the jet engine going to the heat recovery steam generator, where we capture that heat, turn it into high pressure, high temperature steam. It gets routed to a steam turbine, and then the steam turbine uses the energy in that high pressure, high temperature steam and exhausts low temperature, low pressure steam into a heat exchanger, where we recover that energy and sell it as steam. The whole time the gas turbine and steam turbine are producing electrical energy through conventional generators. We're really lucky to have a unique site with natural gas transmission running on the site, a local steam customer, and we have those MISO interconnections that allow us that option of combined heat and power. It's really unique. This CHP is endorsed by the EPA, the Department of Energy, and the Iowa Economic Development Authority as one of the most efficient ways to use natural gas. This high efficiency led to study conclusions to the CHP option. The other great parts, we've been doing this for over 20 years, and it's been a great win-win for all MPW customers. So what makes CHP so efficient? Well, combined heat and power units maximize efficiency by production of both electricity and steam at the same time. By capturing and using the heat that would otherwise be lost, a CHP can achieve efficiencies of 65 to 75% as compared to 30 to 50% for typical technologies. Just order of magnitude, the average car is about 30% efficient at taking the fuel that's in the tank and turning it into work. These higher efficiencies result in reduced total fossil fuel use, reduced greenhouse gas emissions and other air pollutants, along with reduced water consumption compared to conventional power generation. This is a high-level timeline for the CHP project, and it lays out the major steps and multiple board decision points. The development timeline would be a little over 5 years. The generation team's currently working with Stanley Consultants to evaluate equipment configurations and the economics to make sure we get the right size for Muscatine's current and future needs. All the units being evaluated are going to be capable of burning hydrogen. And this is important since hydrogen is being developed as one of the storage medias for renewables in the future. The study started with 10 potential sizes and 4 plant configurations. We're narrowing it down to 2 sizes to further refine the cost estimates and come up with a large and a small output unit. The next step is to rerun the power supply study with updated costs, performance, and sizing for both the solar and the chip. We're going to be sharing those results with the board trustees. And then the next phase would be the design contract that would further refine the costs. That's the first phase. It'd take about a year. Procurement and construction is about 4 years. One of the key pieces, the power supply study recommended continuing operation of Unit 9 until another generating asset is in place. This timeline is aggressive, and it doesn't include any delays. In keeping with our core value of environmental stewardship and protecting the land, water, and air to the best of our ability, the proposed energy portfolio makes sense. Decreasing our carbon footprint will have a positive, long-lasting impact on the environment. We expect to see a 25 to 30% reduction in CO2 emissions with the retirement of Plant 1 in 2023 and a 60 to 70% reduction with the shift from coal to natural gas in 2028. As our power supply transitions, we'll also see reductions in NOx, SO2, PM10, 2.5, along with reduced water usage from both the river and aquifer. As modeled, there isn't a significant cost difference between the power supply study recommendations and maintaining Unit 9 with the anticipated future environmental costs. So by the numbers, the cost to build Unit 9 in 1980 was about $250 million. It cost about $680 million to build that same unit today. The solar array will likely be a PPA with a solar developer. As a municipal utility, we don't pay taxes and can't monetize the current federal tax credits. So working with a developer, this will allow us to see some of the benefits of those tax credits. The capital for this project, 30 megawatt array, is estimated at about $40 million if we were to build it ourselves. The chip unit was modeled in the power supply study at $132.7 million for a 120 megawatt unit. Stanley Consultants is investigating the units in the 50 to 110 megawatt range to find the right size for Muscatine, so this cost could come down. Environmental compliance costs for the existing units are over $40 million and are expected to change with the current administration. The environmental compliance timeline for existing units is really driving this project schedule, which hits a major milestone in 2028. Decommissioning costs for the existing units are estimated at about $20 million. Gage?
Thank you so much, Doug, for walking through that. Next, I'm going to walk through a handful of additional considerations to help put some additional perspective on our power supply planning efforts. First, I want to go back to this model that I presented earlier, and now that you have heard some more details from Doug on our plan, look at how does our plan stack up against this model, and we really feel that our plan currently really checks all the boxes on this. First, on reliability, having that local dispatchable resource in our system really helps improve the reliability of our system. That can accommodate changing dynamics on the market and ensure that we can provide strong local voltage support to our system. On affordability, we really feel like this plan can achieve our goals while really maintaining reasonable rates. We're looking at just modest annual rate adjustments that would be similar to the rates of inflation that we expect to see in the coming years, which really is a pretty significant accomplishment considering the magnitude of the transition that we're undertaking. From a flexibility standpoint, as Doug talked about, having that open portion of our portfolio really leaves room for us to continue to adapt and maybe add pieces into the portfolio down the road as technologies improve and costs come down. And also having that dispatchable resource gives us the flexibility to adjust with changing market conditions as we go forward. And we expect to see increased renewables on the system, which will increase variability and fluctuations of pricing and energy on the system, and having a resource that can move with those prices, we think will be really important. And from a sustainability standpoint, as we've talked about earlier, we're targeting some very significant carbon reductions, and along with those reductions will also come fewer air emissions and reduced water usage, which we think will have a very positive impact. Next, I want to talk about a few different aspects of economic development and how our plans will impact the local economy here in Muscatine. First, unfortunately, with the planned retirement of Plant 1, Units 7, 8, and 8A, we do expect that will impact some of our staff down at the power plant facility. Now, we're going to do everything that we can to try and make that a smooth transition and work with those impacted employees to help them transition into something new, but that is a very unfortunate impact of this plan. Another downside of that is the impact of the local economy. So Plant 1 has an annual O&M budget, not including fuel, of almost $8 million a year. And so those O&M funds, in a lot of ways, go directly back into our local economy, and those unfortunately will go away when those units retire. I also wanted to talk about the economic development impacts of different resource options. So when we look at the solar garden project, very positive on a temporary basis. During the construction of that project, it'll likely bring in dozens of jobs into the community to build that project and get it in service. But unfortunately, we don't expect very many, if any, permanent jobs associated with that, just due to the way that the O&M on those projects work. This most likely would be served in part by a regional crew that would just come into town occasionally, do whatever maintenance is needed, but not necessarily require any permanent jobs in Muscatine. The CHIP project, on the other hand, would also bring many construction jobs during several months of construction of the plant, but then also create several permanent high-paying local jobs to support the unit's operation. And in our case, we'd be able to retain several of our existing talented and dedicated power plant staff to operate that unit. As well, it would have an annual operating budget that would continue to support the local economy in the years to come. Next, I want to talk a little bit about buying energy out of the wholesale market. As we've discussed, using the market for a portion of our portfolio, we really think could increase flexibility and provide some benefits to the community. However, too much reliance on that wholesale market really can bring about a significant amount of both financial and operational risks. It's also worth noting that our forecast and what we see continues to show that the market will be served in large part still from fossil-fired units in the years to come. The first graphic there shows a forecast from the Energy Information Administration, and this is just from earlier this year. And as you can see, their forecast shows all the way out through 2050, still an 11% share of the energy market would be served by coal-fired units, and then over a third continuing to be served by natural gas units. The next is from MISO, the wholesale energy provider here in our area. This is a forecast they use for planning activities. And as part of that, they developed three different futures. The first future is kind of their baseline assumption. And as you can see, again, out through 2040, still expecting to see a little bit of the portfolio supplied by coal-fired resources. And again, a pretty significant portion continuing to be provided by natural gas resources. Here's another slide from MISO, and I won't go into a lot of detail on this, but MISO's had an assessment going on over the last several years looking at the impact of increased renewable resource penetration on the grid. And what their studies have shown to this point is that there's kind of an inflection point right around the 30% mark. So when renewables start to make up more than 30% of the portfolio, that's when MISO forecasts they will start to have a pretty significant impact on the complexity of how the system operates, and concerns with operating the system reliably. Also, they expect to see a significant increase in costs associated with adding more renewables to the system because of the transmission investments that will be needed to move that renewable energy around when it gets above that threshold. Next, I want to talk a little bit about the Arctic storm event that happened in February of this year. So depending on when you listen to this recording, this is probably still pretty fresh in many people's minds. It was a very significant impact, and even though we were spared much of the impact here in the Midwest and in Muscatine, Texas had a very unfortunate experience when this Arctic storm hit. This slide shows trends of energy production from different types of resources in the ERCOT market in Texas during that time. And this first blue circle here shows energy production on Monday before the storm really hit. And what you can see is that this green bar shows wind production during that time. You can see it was upwards around 22,000 megawatts of wind energy during that day. But then as the storm rolled in and the demand really went up during the very, very cold temperatures, the wind generation really dropped off significantly, dropping to almost zero here on Tuesday the 16th. And I don't think that had as much to do with icing on wind turbine blades as it did that there just wasn't wind available to spin the turbines, and so that energy wasn't available to the system. You can see that gas-fired units made up the difference for many days, but then this is about the time when they were hitting the coldest snap, and some of the gas units then were forced offline because they couldn't handle the cold temperatures. And with the renewable resources down and the gas resources down, there just wasn't enough generation on the system to serve demand, and that's when they started to see the rolling blackouts. So there really was several different factors that contributed to that. But one of the important things to note is that intermittency of renewables, as you can see from this graph, was certainly a contributing factor. What was happening in MISO at that time? You can see here the almanac from the temperatures during the event here in Muscatine. So pretty cold temperatures, but not anything too out of the ordinary for what we might expect here in the Midwest in February. This next snapshot shows real-time energy production in the MISO market on the 16th of February, so kind of right in the middle of the event. And you can see over 50% of the energy being produced in MISO at that time was still coming from coal-fired resources. And then about another third was coming from natural gas-fired resources. So altogether, about 80% roughly of the energy produced in MISO during that event were still coming from fossil resources. And that's not to say that we won't continue to see the percentage of fossil resources come down in the coming years. We won't see the increase of renewables on the system. But this just kind of highlights the magnitude of the challenge that we really have to overcome when over 80% of your energy during a major event like this is still coming from those fossil resources. The next graphic really highlights the financial impacts of this event. This is real-time pricing in the MISO footprint during one of the days of the event. I note here that the typical price during this time is around $27 per megawatt hour for wholesale electricity. As you can see in the parts of Texas and Louisiana where the impacts were the worst, they were seeing prices of over $1,000 at this time. And even in the upper Midwest, we were seeing prices over $200. So you compare that to the average, that means the prices were about 10 times what we would normally see during that time here in Iowa. And down in the southern part of the footprint, much higher. And these prices didn't last just for a few hours. They lasted for several days during that event. And we note here, we've done some of our own analysis that if we did not have our local generation resources during this event, those real-time prices would have cost our customers an additional $2.5 to $3 million for power supply expenses just for the 3 to 5 days of that event. So it would have been a very significant impact on us had we not had those local generation resources available. Going back to our model, if we were to go to a very significant portion coming from the market, how does that stack up? Unfortunately, it doesn't look quite so good. From a reliability standpoint, too much dependence on other entities to provide support to your system. And we do expect, just like that February storm highlighted, we expect that the grid will become more and more unstable as we go through this major transition, and that could have significant reliability impacts if you have nothing else to support your own system. On a reliability or affordability standpoint, it's a question mark. There certainly could be some lower pricing at times, but the prices in the market are much more volatile, and you would have nothing locally to hedge against those real-time prices. Now, we would do a lot to hedge the risk as much as we could, buying a certain amount of energy in advance, but some of those real-time events can really sneak up on folks and have a significant impact. From a flexibility standpoint, it would be a very open portfolio, so we could add additional resources if it made sense down the road, so that would be beneficial. But in the meantime, without our own resources, we really just have no way to respond to volatility in the market. On a sustainability front, still a question mark. So because the chip units that we've evaluated are very, very efficient, they have a pretty low carbon intensity. And buying out of the market in the interim would actually have a higher carbon intensity than what we forecast with our solution, because there's still so much fossil units on the grid, as we've shown. And then if you do rely on others in the grid to reduce carbon, then those decisions really are outside of your control. I want to go back again to this model of a 100% renewable portfolio. Doug talked about the challenges that come about with that and the costs associated with installing enough, say, solar and battery storage resources to try to accommodate supplying the city of Muscatine with our resources around the clock, costing us over $1.5 billion just for Muscatine. Our estimates, because of those high costs, show that our rates would have to roughly double to accommodate that solution. And that would have a pretty significant impact on many, many households in this community. Some folks might be able to accommodate that kind of premium. We have a lot of folks in this community that really could just not accommodate a doubling of their electric bill. Also, from a business perspective, the utility bills for our businesses are a big part of what allows them to compete or not compete in their industry. And if they had to double their rates, that could significantly impact their ability to compete in their marketplace, which could unfortunately impact jobs in our community as well. One thing I think is really important to note is the difference between adding renewables to the system versus transitioning to 100% renewable supply. The premium to just add some renewables to the system is not that significant. We're looking at pricing to do our 30 megawatt solar garden. Just to add that onto the system and sign a PPA, we still see that as coming at a premium, but it's a manageable premium. The challenge really comes in is when you don't have any other resources to fall back on and you have to overbuild enough solar and wind, intermittent resources and battery storage to really accommodate the system 24/7. That's where it really gets expensive because you don't have anything to fall back on. So you have to overbuild those intermittent resources and add a significant amount of storage to be able to accommodate all those contingencies. So again, just really important to note, to go out and just add some solar or wind to the system, not too much of a premium, but to try to transition to only renewable resources and storage, very, very costly. And that's what leads to our estimate of doubling electric rates. Going back to our model, how does a 100% renewable supply stack up? And unfortunately, it just doesn't look so good at this time. From a reliability standpoint, having no dispatchable generation really means that you're riding the wave of the market and you're relying on others to supply your system with reliable power. And then, as anybody with a cell phone knows, when the batteries run out, they're out, and you have to wait until there's another resource available to charge your batteries back up to supply the energy. From an affordability standpoint, as we've shown, we estimate a roughly doubling of our electric rates, and that would have a significant impact to all of our customers. From a flexibility standpoint, that limited diversity really would be an issue. Yes, we would diversify between solar and wind, but you're still looking at all essentially intermittent resources in your portfolio. And that wouldn't really allow you to respond to market variability as those intermittent resources fluctuate. From a sustainability standpoint, certainly this would be the most sustainable solution. But again, I say mostly carbon free because no matter what amount of renewable and storage resources we install, there is still be times that we would be relying on the market for certain portions of our energy supply, say when we have equipment that's offline for maintenance. And as our forecasts show, we do expect that market to continue to be fueled by fossil-fired units for many, many years to come. So there still would be some carbon intensity in our supply. And then it's also worth noting that wind turbines, solar panels, batteries, they all have their own environmental impacts when you look at the whole supply chain. And so while in the production of energy themselves, there's no carbon, they do have some other environmental impacts that should be considered. Next, I want to talk a little bit about the benefits of local generation. And we know this well because we've done it for almost 100 years now. Those local resources provide high quality, reliable power to serve our system and provide voltage support for our load. They also serve as a hedge against market risk from a pricing standpoint. Also, the ability to make decisions on how a unit operates and having that control in our hands versus relying on somebody else certainly provides some benefits. Also, as we've talked about, the local impact, having those local resources feeds money right back into the local economy to support the operation of those units. When we look at the combined heat and power solutions, again, we've got over 20 years of experience with this type of operation, and we've shown that it is a win-win and provides benefits for all of our electric customers. We also have a site that has existing substation capacity, gas connections nearby, and existing MISO transmission service. We think it makes the most sense to leverage those resources that we have available to us to serve the community going forward. We also have a highly skilled, highly dedicated labor force here in Muscatine already, and we think it makes a lot of sense to leverage those resources and utilize those crafts to serve a new local generation resource. I also wanted to talk about future carbon reductions. So a lot of utilities are looking at plans for how to transition to a carbon-free or carbon-neutral power supply, and a lot of utilities have started to put a target of 2050 out there as their goals because they see the challenges that they will need to overcome to truly get to that carbon-neutral solution. And with our plan, we really see a 2050 timeline being achievable as well. There's a significant amount of research and development being dedicated to renewable hydrogen fuel technology as well as carbon capture technologies. And if we were to develop a combined heat and power unit in Muscatine, we would ensure that we would have the ability to convert to renewable hydrogen fuel down the road, which would allow us to ultimately still get to a carbon-free or a carbon-neutral solution. We also looked at a solution that's right for Muscatine. We have a uniquely high commercial and industrial load here in Muscatine, and that's been a good thing for our community, but it also means that reliability of electric supply is paramount to those business customers. It also means that local voltage support is really important. Industrial loads typically are what we call inductive loads, and that tends to draw the voltage on the system down. And the farther away your generation resources are, the harder it is to provide strong voltage support to those types of loads. So having a local power generation facility will help maintain that voltage on the system. We also have the unique circumstances of having a customer that has a high process steam demand, and it provides for that unique opportunity of a partnership. And again, we've leveraged that partnership for over 20 years now, and it's been a good win-win for all of our customers during that time. And so we think it makes sense to continue to explore that partnership in the future. And we really think that we can achieve significant environmental gains while also balancing affordability by taking advantages of our unique situation here in Muscatine. What's next? We're going to continue to analyze and evaluate the study recommendations. There are still several steps involved in this process as we continue to move forward. The study that Doug talked about really was looking at a very high level and looking at indicative pricing estimates for these different resources. Now we're moving into the next level of digging in deeper, evaluating pricing at a more granular scale. First step being embarking on an RFP process for that local solar garden, so get firm pricing from developers for that solution, and also moving into a next step analysis on those chip options. What really are the capital costs? What are the sizes and O&M costs associated with those different solutions? We're also analyzing staffing needs. As we mentioned, unfortunately, there's expected to be some staffing impacts, but we also mentioned that it's really important to continue to operate those plants reliably in the coming years. So trying to find that right balance going forward. And then continue to engage the community in this process. We've been very transparent and very open in sharing information, met with different organizations in the community that are interested in this topic, sharing information at our monthly board meetings, holding this customer forum. And we'll continue to get more and more information out through our website, through social media. So keep our customers informed of our plans as we go forward. So in our live session, as I mentioned, we had a Q&A, so we won't be able to replicate that in our recording today, but we have a website set up that's dedicated to this initiative. So if you just go to Google or Bing and put MPW Powering the Future, it should bring you a link right to our landing page on this topic. And we've provided a lot of background information there. We're providing key updates on that page, as well as we have an FAQ set up, and we're going to continue to add FAQ answers on almost a weekly basis as we go forward. So as we have topics come in, people are interested about, we're going to provide information to answer that question as it relates to this initiative. So be sure to check that out. And as always, if there's a question that we haven't answered on our webpage, you can submit that question through our website or call in to 263-2631, and we'll be able to get you the information that you need. So thank you so much for those that stuck with the recording all the way through the end here today. And thank you for your support of MPW going forward. Have a great day.